Okay, ladies and gentlemen, let's talk about triangle congruence. Now, the thing about triangle congruence is the fact that we're going to use side, 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 angle, 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 side, and HL to determine if all these triangles down here are actually congruent. Now, here's the thing about it. We can only use those 5 rules. So what we're going to need to do is let's figure out from this what we have going on here. And let's get a couple labels put on where they need to be put. Here we go. In this first triangle, we know that we have an angle here, and we know that we have an angle here. So we have a set of angles that we can work with. Additionally, we know that we have these right angles, that right angle there, that right angle there. That is a whole nother set of angles. Now the question becomes, is the side in between here, or is the side out here? So the question becomes, as I walk around a triangle, so we'll make a little picture here. Boop, 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 boop. As you walk around this triangle, da-da-da-da-da, 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 what do you come to first? Well, you started right here at an angle. Then as you moved along the triangle, you came to another angle. So there's nothing in between here because I don't know this side, have no idea if that side's congruent to something else. On the other hand, as I walk right up this side right here, you say, well, I don't know anything about that side. I didn't see any labels on it. Well, that's okay, because is this side in the triangle off to the left and the triangle off to the right at the same time? If it is, then what we're going to say is that's congruent by reflexive property. Reflexive property. And so now I have an angle, and a side. Now let's walk around this triangle over here. If I start here, I have an angle, and then I have a side. So by angle, angle, side, I can prove that these two triangles are congruent. So by angle, angle, side. Now let's go over here. I can clearly see I have this one and this one. One out of each of these two triangles, a set of sides is congruent. Now, I also know that I have another set of sides, and those are congruent. So the question becomes, do I have another side or angle? So is it another angle or another side? And is it here? Is it in the middle? Or is it back here? Well, in this particular case, there is nothing labeled on this side or this side. So I can't say that those sides are congruent. And just because two sides are congruent does not make the third side congruent. It does work for angles, but it does not work for sides. Now, the other thing I can take a look at is, oh, well, what about angles? Like this totally looks right here as if it should be totally the same as this one over here by alternate interior angles. But the problem is I don't have parallel lines. If I don't have parallel lines, I can't say anything about that angle. I can't say anything about those two angles, because these two lines, even though they look parallel, it does not say they're parallel. So just because they look parallel or look congruent does not make them congruent. On the other hand, I have this angle here and this angle here, and they're across a vertex from one another. The nice thing about that is, if I have two angles from intersecting lines, I have vertical angles without having to have parallel lines or congruent sides. Automatically, those are congruent. So now I have this angle congruent to this angle. And again, if I walk around this triangle, I have a side, an angle, and another side. So that angle is pretty clearly side, angle, side. And if I go up here, I can say, by the way, you'll notice since I started with 2 lines, I'm going to start up here. I'm going to say side, angle, side. So I have side, angle, side. So thus far, I have had an angle, angle, side because I had angles. I had angles with the side over here in the third position. I've now had side, angle, side because as I walked around, that's the order that it came in. Let's go on ahead and let's come down here. And with this, I have a set of sides. I have a set of angles. And here's the deal. They mark this one as a right angle. Well, if they mark that as a right angle, that means this line here and this line here are perpendicular. Perpendicular. If 2 lines are perpendicular, they make not just one right angle, but they actually make 4 right angles. So automatically, that's a right angle. Those 2 are going to match. So I have side, angle, angle down here in the middle. Side, angle, angle. Now, side, angle, angle would be the same as angle, side, side. So here we go. But let's say, well, wait a minute, Mr. Moore, what if I didn't know that was 90 degrees? Well, is this a set of intersecting lines? So do you have vertical angles even if you don't have right angles? Well, sure. So in this case, I have side, angle, angle, because I had to skip the side. Side, angle, angle, because I had to skip the side. So side, angle, angle, which is the same thing as angle, angle, side. All right, so let's go on to another one. Now, as you start to look here, you should see that we can make this a lot quicker by moving a little more quickly as we get used to this. So in this case, I have a side, that's a set of sides. And then I say, oh, I have a side, and I have a side, and that makes a side. Awesome. And then I have vertical angles right here, so that makes, side, angle, angle. It is totally okay to have angle, angle, side, 2 angles with a side, but I cannot have 2 sides with an angle. That doesn't work. But we're saved here a little bit because is this a right angle? If it is, that makes this a right angle. And now instead of having to have side, 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 angle, side, angle, side, angle, 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 side, I can use this guy, HL. And remember, HL is hypotenuse, leg. Hypotenuse, leg. So if I have hypotenuse, leg, that means in any 2 triangles, I can't use angle, side, side, but if they are right triangles, and I know the hypotenuse is congruent to hypotenuse and legs are congruent to legs, then that means I can use HL in this very specific situation. And the reason I can, remember, ladies and gentlemen, is because unlike a triangle here that is not a right triangle, I can't use a squared plus b squared. I can't use a squared plus b squared equals c squared. I can't do that over here because it's not a right triangle. But if I have a right triangle here, I totally can use a squared plus b squared equals c squared. And if I have a squared plus b squared equals c squared, it means if I know this and this are the same, and this and this are the same, because and only because it's in a right triangle, I can totally say these 2 are the same. But in this case, I'd have to do this, and that would be side, side, side. I can cheat and say, well, wait a minute. I don't need to prove this congruent to this, because if it's a right angle, I already know those are going to be good. I'm good enough just knowing the hypotenuse up here and the leg over here. We can prove it by HL. So by using HL, it is not a problem whatsoever.